Alright, time for another DraftPhysics.com video presentation. I debate physics also. And, but we have to find a person to debate. We have people to debate, frankly. Arguments on the subject would be really nice. So, I am going to start playing with Wikipedia a little and try to see how long I can last without getting booted for some pointlessly stupid reason. They'll make up some kind of thing like I did something horrible or harassing or some other kind of nonsense. I sort of relate to this idea of, okay, so the first article I looked up was thrust, and it's really a nothing article. I mean, it doesn't say anything about the subject, frankly. It shows you lots of airplanes, talks about airplanes, no indication that thrust has something to do with something you do in space. Something that propels you to Mars, for example, or something. Just nothing. Absolutely zero real conversation about the nature of thrust, except in a context where it's fighting some sort of drag. So outside of some sort of thrust to fight drag, there's nothing. It's not about pure acceleration and pure velocity. All right, and it's because the whole space argument does destroy any hope of people maintaining a credible argument that kinetic energy is real. That 1/2 mv squared has anything to do with reality, because in the real universe it doesn't do anything. It has no function. It has no power. So I'll read what I posted, and as a part of the talk. It's not a claim to edit. It's just a talking about editing. And even in talking about editing, you're not allowed to talk about the subjects, right? So I don't know exactly what you're supposed to talk about, is whether we trust Feynman or whether we trust Einstein or whether we trust some other authority. And so I guess the only thing you can talk about is what authority can be trusted. But the subject itself, who cares? How, piecemeal and nonsensical what the article actually says is the truth, what science says, when the science is mush, and you can't get these simple straight answers. So we landed on the moon. Did the lunar module use the kinetic energy formula, or did it use momentum to land on the moon? And this is kind of a decisive question, right? I mean, can you honestly say, oh, it doesn't matter? No, you can't really honestly say that. It's a critical thing, right? If you can't move matter in empty space with a form of energy, momentum versus kinetic energy, if you can't do it in space, in the vacuum of space, then isn't it nonsense to call it energy? If it doesn't work in the vacuum of space, is it qualifiable as a real thing? So if momentum is what got us on the lunar surface, then shouldn't that be like the end of the conversation? I mean, Newton's laws were all written about momentum. They weren't written about kinetic energy. They weren't written about Leibniz's theory. They were written about Newton's theory. Newton's laws are about Newton's understanding of reality. It's just so bad. So here's the simple diagram. Now the article won't answer this question for us, okay? So the article on thrust won't answer this simple question. So I have a spaceship. I'm flying in space, and I have this capacity to throw thrust out different sides to navigate, because I want to get somewhere, and I have to point in that direction to get there. Okay, so who cares what's coming out this end? We really care about what we're doing here. Now we could tilt this and also do the same thing, but we're going to use thrusters out the side. And the simple argument is I can throw a 1 mass out this side, okay, going 1,000 velocity, or I can throw a 1,000 mass out this side, going 1 velocity. All right, and the fact is momentums, they'll be the same, right? It'll be a big giant m here and a little tiny velocity, and a big giant little tiny m here and a big giant velocity, and these two things will equal each other, so the spaceship will go straight. Now the problem is, but wait a minute, this is 1,000 times the kinetic energy. So I have 1,000 times. I mean, big fat arrow. I have a big gigantic kinetic energy arrow going that way, and I have a little tiny feeble kinetic energy going this way. Okay, 1 here, 1,000 here. Huge energy differential. Obviously, the spaceship should go flying this way because of the equal and opposite reaction. So right here in the very beginning of this thing on thrust, it says thrust is a reaction force described quantitatively by Newton's third law. Well, then kinetic energy is out of the question, right? Because this isn't Newton's third law. 1 joule this way, 1,000 joules that way. Oh no, that's not Newton's third law. You can't do that. So I mean, can somebody please explain where I said something that's wrong or a lie here somewhere? Or somehow I'm posing this question and asking the simple question, well, what do you say happens? And if you concede that this happens, momentum is in charge and the spaceship continues to go dead straight. Now, if you concede that happens, don't you have to concede that kinetic energy isn't real energy? Because it obviously isn't working. It can't move matter. I have 1,000 differential in the joules here. I have 1,000 watts over here. I have 1 watt over on this side. I sent 1 watt into space over here. I sent 1,000 watts into space over here. I have to turn if you're going to obey Newton's third law. So you've got to concede kinetic energy has nothing to do with thrust and has nothing to do with moving matter and has nothing to do with doing work. You have to concede this is doing work. Moving the spaceship is work. Kinetic energy can't do the work. Momentum does the work. Momentum is real, and the kinetic energy theory is a fable. Okay, that's all it is. It's a silly little fable. There is no 1/2 mv squared. There's no v. There's no such thing as a squared velocity. Velocity isn't a dimensional. It's a vector. It's a line with a magnitude, a length. That's all it is. It doesn't have any dimensions. It's a one-dimensional object. It's just so annoying. But anyway, so yeah. So I'll read my addition to the subject, what I wrote them, in saying that clearly the Wikipedia article on thrust should answer this question. Which one is going to decide? Kinetic energy theory or momentum? Which one? If kinetic energy is the truth, then the spaceship turns. If momentum is the truth, the spaceship keeps going. That's the simple fact. One of them has to be right and one of them has to be wrong. One of them works and one of them doesn't. It's just so frustrating that people can't play fair and, complete their obligation here, which is to explain where I said something incorrect. All right, so this is what I wrote. All right, I should be able to see that. All right. Okay, so I said, what about thrust in a vacuum? This article seems less than scientific. Thrust should be designated as a form of energy. Now, doesn't that seem pretty important? Did you say right from the beginning thrust is energy? It's moving mass. Moving mass is energy. The question that should be explicitly answered is the energy momentum, or can it be properly measured as kinetic energy? In vacuum of space, navigation, using the kinetic energy formulation, 1/2 v/mv, will not accurately predict the outcome of a given thrust will produce. Now, that's my claim. Now, again, we have no authority that we know of. I mean, I guess I could play physicist Michael's kind of weak concession that, yes, the spaceship doesn't turn. So even though I have 1,000 watts going one way and only 1 watt of energy going the other way, somehow the spaceship doesn't turn. Nor will it accurately predict what force is required to produce that thrust. So obviously, if you want to know how much energy you need to make something happen, well, the fact is it's going to be the same momentum-wise. And that's a big problem. if kinetic energy doesn't work as an outcome, then you have to consider that, well, somehow you're saying that somehow I made more energy go one way than the other way, so there's no Newton's third law for kinetic energy. It doesn't work. Anyway, I mean, I could just have the gun and the bullet, right? The recoil of the gun is going one way, the bullet's going the other way. The bullet has 1,000 times more energy than the gun recoil. Thrust proves momentum is the only form of real energy. If this article is to be defended, you should have a credible testimony of a physicist stating that thrust applied in outer space has performance that is consistent with the kinetic energy theorem. That somehow, somewhere in space navigation, the kinetic energy theory works. All right. You should also note that the article makes no mention of the thrusters used to navigate in vacuum. So they don't pay any attention to where the idea of thrust and thrusters are vitally important, which is navigation in space. Simple question. The article should be, I mean, you can't use propellers in space. You can't use a bunch of, this all you got is thrust. There's really no other way to get anywhere than to do the Newton's third law thing, is to let something go. Let some mass go at a velocity. Simple question. The article should be able to answer. If I throw 1 unit of mass moving 1,000 miles per hour out one side of the spaceship and simultaneously throw 1,000 units of mass going 1 mile an hour out the other side, does the spaceship turn? So I've been asking this question for 2 years, and we've got nobody, just about nothing, where somebody will just explicitly answer the question. If it doesn't, how can kinetic energy be considered real energy when I have thrown 1,000 times more energy one way than the other? So how can it be possible that I physically produced 1,000 watts one way and physically produced only 1 watt the other way, and yet the spaceship doesn't turn? How is that physically consistent with anything reasonable in physics? So that's it. So we'll see if we get anything back besides some snarky shit. Anyway, so what else? Anything else to do with this? Yeah, so I'll read some of the article itself. It's just so lame and empty. Thrust is a reaction force. So again, it should just be pointed out. It's a force. It's converting matter. It's giving matter momentum. It's giving it velocity. And when you give matter velocity, then you are stuck in this obligation where, you have to obey the third law. That is, if you're giving it away, you have to lose it. So you're giving a direction away. You're throwing something away that has a direction. You had that direction. Now you don't have that direction. And now you're minus the direction you gave away, which is the way I would say it. Anyway, when a system expels or accelerates mass in one direction, the accelerated mass will cause a force of equal magnitude. So how can it be a force of equal magnitude when the gun has 1 joule and the bullet has 1,000 joules? How is that equal magnitude? But opposite direction to be applied to that system. The force applied on a surface in a direction perpendicular to the normal. So this is, to start right in the first sentences, right? This is only the second sentence, third sentence. Just start talking about perpendicular. It's, they're getting into, obscure, angular introductions of thrust. And there's no such thing as a normal, in space. There's no normal in space. The force applied on a surface is in a direction perpendicular or normal to the surface is also called thrust. So I don't know where they got that from. I wonder what book says that silly sentence. Force and thus thrust is so force. They start off force and thus thrust. So they're conceding thrust is a force. Well, it's not obeying the kinetic energy rules. Can they concede the point? Is measured using international system of units in newtons. Right, so we're talking about, kilograms per or pounds per, which gets all very mushy. Obviously, Newton thought of things in terms of pounds. foot-pounds, and represents the amount needed to accelerate 1 kilogram. So, obviously a foot-pound would be 1 pound of mass at a rate of 1 meter per second. So the point is that 1 mile per hour, which is a lot slower. No, it's a lot faster. Anyway, is the number I think that's accurate. But anyway, in mechanical engineering, the force orthogonal to the main load, such as in parallel helical gears, is referred to as static thrust. So is it just amazing that they would put all that kind of crap, some complex gear system or something, into a conversation about what's the nature of thrust. And the nature of thrust is you're giving mass velocity, and the thing that gives it velocity has to lose velocity in the direction it gave away, kind of obviously. That's the equal and opposite reaction. If I'm going 10 miles an hour and I hit something that weighs the same as me, theoretically, I give it the 10 miles an hour I had, and now it has it. That's the Newton's cradle. So it's just, and then so right here, right as examples, it's all this fixed wing propellers, rotary wing, motor boats, rockets leaving the atmosphere, okay, but nothing about the real terms. And clearly the formulas for the formalizations don't use the mv squared, even though they subtly imply that somehow they should be, because they actually do start talking about F equals ma. Somewhere in here there's a little F equals ma thing, but there's no visualization of them actually saying showing you any squared velocity term. So clearly kinetic energy has nothing to do with it. There's no sign of it anywhere. So here you have it here. When incoming air, so now they're talking about the turbulence, all kinds of effects that you have when you're talking about moving air. Okay, that's not what we're talking about. The point is releasing something, not moving something. All right. So, and then there's all this thing about jet engines. Okay, still no squared terms. It's basically a concession that this isn't about kinetic energy, that thrust doesn't have anything to do with the kinetic energy theorem. Just Boeing, they're just talking about Boeing engines. Again, just all this completely terrestrial thrust, and no conversation at all about, what I would argue is the part that's really interesting about thrust, the Star Trek kind of, the fact that you have to, navigate with your impulse engines, that thrust is about this whole idea of you having to shoot something. You have to give something away, or you have to collect something and then spring it and shoot it away. You have to use some sort of mechanical force you have to apply to a piece of matter to create thrust. Or you can just do it by shooting photons. You can convert your mass into some other form of radiation, some other speed of light radiation, and accomplish the same task. But obviously you need to do quite a lot of it, to create the wattage, the power necessary to actually move anything. So anyway, it's a crappy article, very unscientific in the sense that it doesn't even explore the subject with any kind, even close to completely, or it just doesn't even really touch the subject at all, and doesn't give you any indication that the subject really is about a nozzle, and it's about how you release the stuff you're releasing, and how you can maximize its velocity to increase its momentum. Nothing, and they don't even use the word momentum. Well, here we go. All right, here we go. A rocket is propelled forward by thrust equal in magnitude but opposite in direction to the real time rate of momentum change. So again, not the kinetic energy change, the momentum change of the exhaust gases accelerated from the combustion chamber. So we're just talking about the relative difference between what you're releasing, the speed of what you're releasing versus your speed. And that'll tell you how much momentum you're going to gain. And it's telling you exactly how much force there is. So it's exactly consistent with what Newton said. Force is momentum. Force is not mv squared. All right, so that should be enough. So I am working on the website, doing some different things. I guess I could show you. I've simplified it grotesquely, okay, because Google doesn't give me, does zero exposure to any of the content on the websites. So they provide no links at all. And, I'm going to call them on that and force them to show up with something, just to demonstrate that there's some reason none of the content, none of the words on my websites are ever relevant. That's essentially Google's claim. And I say bullshit. I should get at least one a month, something would show up. I mean, in the past, that's the way the internet worked. I got lots of views from my content. Not lots, but I'm saying if you typed in a relevant sentence, it showed up. Now, even when you put direct quoted text from my web pages into Google, it still doesn't show the page. So even when you directly quote what's on the page, they're not referencing it. So it's really quite bogus. Anyway, so yeah, made it really simple. Also, it helps, I guess, with the whole phone thing. People just, makes big giant buttons easy to hit. So we'll just keep everything very simple. And, easy to scroll. And then you can play the video if you want. And I'll have the text below which I'm going to be editing and creating new text and blah, 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 blah. So I mean, this 2+2 page, I did change that a little bit. So that'll be, I have nice definitions here. So maybe we'll go through the definitions of all the basic concept words, and then we'll go through the basic laws. Like Newton, I'll just write a bunch of laws, and make it, it's not going to be 3 of them. There's going to be more than 3. But anyway, in some ways, you don't need more than Newton's 3 laws, but you have to add all the extra stuff. It's not about mv squared. You have to add all that stuff, or they'll screw it up. All right, so that's probably enough. So till the next time, and such, and so forth. Like I said, I'm working on trying to get an audience. I've been emailing people who comment on other people's videos to see if that'll do any good, but nobody has email addresses, which is kind of depressing and annoying. So sometimes you have to just comment on their page, which is I don't like spamming people, but whatever. I mean, spamming a comment section, but whatever. It's just too silly. So till the next time, and such and so forth and whatnot. It's just, God. I hate it on this planet. It's just such a bunch of jackasses. Just everywhere. Every person, you scrape them just a little bit. Whoops, jackass. Just, little tiny. Just, jackass. Yeah. Fuck.